Example number 7 coming up here is another example of where we are going to have to graph a hole in our rational equation. So first step, like always, factor on top and bottom. And it looks like we're going to have something to cancel. Remember, before we do that canceling, though, let's check out our domain. Our domain here will be from negative infinity until negative 5, then from negative 5 to 4, and from 4 to infinity. That's where our denominator equals 0. The two places where the denominator equals 0 were at negative 5 and positive 4. So first, now that I've canceled that out, let me just rewrite that. 1 over x plus 5 is basically the equation that we are working with. The x equals negative 5 did not cancel, so that will be our vertical asymptote. The x equals 4 did cancel, so that's going to be our hole. And remember from the last example, we're going to have to eventually find a y value, so why don't we do that right now? The y value happens if I go and plug 4 in now into my new equation. Well, that's actually going to be really easy. The y value is 1/9. So there you already have a hole and a vertical asymptote with which to work in this problem. We also have to find an x and y intercept, so let's do that. Our x-intercept happens when the y value equals 0, meaning the whole function equals 0. So what happens here, if I set that entire equation equal to 0, that means the numerator is equal to 0. Well, 1 never equals 0, so I don't have an x-intercept. Interesting. Be careful, because you could have done from the original, you would have gotten x equals 4, but remember, 4 does not exist in your domain. That's why it's always easier and smarter to use your factored equation. Same thing with this. For y-intercept, meaning plug 0 in for x, a lot easier to use it in that purple equation, and you get a y-intercept of 1/5. So 0, 1 over 5. Pretty straightforward there. And all you have left now is horizontal and slant asymptote. And actually, this one's really easy, because if you try to do the long division, 1 over x plus 5, well, you can't do that division, because the numerator is already less than what your denominator is. So that means that it's not that you don't have a horizontal asymptote, it's that you've already done the division. You have a 0 out in front, a horizontal asymptote of y equals 0, which makes sense why we might not have an x-intercept, if I bring this back up, because if you don't have an x-intercept, that's because we don't cross the axis, because we have a horizontal asymptote there. So horizontal asymptote is that, no slant asymptote as a result. Crossing, when do you cross the horizontal asymptote, is when the remainder equals 0. It looks like we don't have a remainder. Well, technically we do. Our remainder is this numerator, because remember, 0 is our part in front, so this whole thing becomes your remainder equation. So again, when does 1 equal 0? It never does. That's why it never crosses the horizontal asymptote, which is why we don't have an x-intercept. So they all connect and all make sense with the way the problem is lined up. So now we can graph what we know. We'll start with our vertical asymptote at x equals negative 5. We don't have, or yeah, we do have a horizontal asymptote, excuse me. It's at y equals 0. So there's the asymptotes. The points that we have to plot, we have the y-intercept at 0, 1/5, so pretty small there. And we have no x-intercept, and the only thing left to draw is the hole that we have at 4, 1/9. So right above the axis, and it's going to be tough to draw, but basically you just got to show that we have a hole. See if I can draw a little better. Really, really close to the axis, but not quite getting there. So there's your 2 points. I'm not crossing the asymptote ever, so I need to just kind of come down, connect, and level off, and make sure I don't go through the hole. Something like that. Try to draw that first part just a little bit better. Or kind of, you don't want to go like straight down and straight over, but maybe a little bit closer than what I had. Kind of angle off and something like that. That'd be a proper drawing for that part of the equation. Now, for this left-hand side, we already have one portion, 2 portions of our graph. We need to draw the third portion here, the part that goes from negative infinity to negative 5. And we're going to have either something below the axis or something above the axis. We can't check based off an x-intercept because, well, there is no x-intercept no matter which way you draw it. Your only option at this point is to plug in a number that's in this region. Well, easy number to plug in, just say -10. So if you have 1 over x plus 5 and you're plugging in -10, you're going to get 1 over -5. You're going to get a negative value. That means that you're going to use the bottom part of this equation and draw something approaching the asymptotes below the axis, because that's a negative value. So to make sure, we have a y-intercept plotted, we have a hole plotted, we have a vertical and a horizontal asymptote, and we have 1, 2, 3 different portions of your graph to draw. There's another example of how to use a hole, and especially to graph one with a hole when you have a horizontal asymptote of y equals 0.